Okay, in Module 5, we've been learning about proportions and percents. In Lesson 5.3, we're going to do application of percents, which means we are going to use percents in lots of different real life situations. In the module lesson 5.3, it's just some examples of where you use percents, because we use percents in life all of the time, okay? The first example we're going to use is sales tax, okay? Sales tax is a percent of the price of an item. So if you buy a very expensive item like a car, you're going to pay a percent of the amount of the car in sales tax. So sales tax on a car sometimes is hundreds or even thousands of dollars because it's a percent of the actual price. So the higher the price of the item, the more sales tax you're going to pay because it's a portion or part of that price, okay? So sales tax is a percent of the price of an item. Using the sales tax rate, you can find total cost of the item if you know the price. Okay, if you know the price of the item and you know the sales tax rate, you can figure out what is the total cost going to be. Or you can find the price, right? You can find the price of the item on the tag if you know the total cost. All right. So in this case, we know the total cost. Marcus bought a new jacket and he paid $86.40 for it. That was with the tax. Okay. When he left the store, he paid $86.40 for his new jacket. So the question is, what was the price of the jacket on the tag before the tax was added? So we can figure that out. We're going to write an expression using a variable to stand for the price. Whatever you're looking for in your problem, that's going to be your variable because that's your missing number. That's what you don't know. You don't know the price. You know the tax and you know the total price with the tax, but you don't know the original price, right? And so we're going to let P stand for price. Okay? And we're going to write an expression to figure out how to solve for the original cost of the jacket before tax was added. So price, or P, is 100% because 100% of the price is the price. Well, the tax is 8%. So tax equals 8% of the price. Okay, I don't know if you can read my writing. Maybe I'll zoom in a little bit. Okay, the tax is 8% of the price. So how do we write 8% of the price? Well, of is a multiplication word. So let's talk about what is the total. The total is the price plus the tax, right? This price plus the tax is the total cost. So basically, the total cost is 100%, 108%, right? So let's do price, which again is P, plus tax is 108% of the price, which we don't know, right? Price is P. So the price is 100%. The tax is 8% of that. So the price plus the tax is 108% of the price. Okay, that's a P. Now, how do we write an expression for that? The expression with the numbers that were given in the problem would be the price plus the tax in the problem is $86.40. That right there is the price plus the tax because that's what Marcus paid out the door. Okay. So that is 108% of the price. So the expression for that would be $86.40 equals 1.08 P. That's the expression because it's the total equals, this is the percent as a decimal. And when you put the variable right next to the number, that means multiplication. When you see a letter right next to a number, that means you're multiplying whatever P is times 1.08. And that's going to give you 108% of the price. And we know that 108% of the price is the total cost. Okay, so let's actually solve that. In order to get P alone, which is what we want to know what P is. Since this is multiplication, we're going to do the inverse operation of multiplying, which is dividing. So we're going to divide by 108. If we do it to one side of an equation, we have to do it to the other to make the equation equal. These two 108s will cancel out and we'll get the price equals $86.40 divided by 1.08. So remember, in this module, you can use your calculator. So let's get our calculator out and do 86.40, 86.40 divided by 1.08, 1.08, and we get $80, okay? So we solve for the variable and we get the cost of the jacket on the price tag was $80, okay? This set of notes is 2 pages, so it's going to be a little bit longer because there's lots of different examples and I want you to know how to do the examples. Here's another example, okay? This says Terry deposited into a bank account $200. All right, Terry deposited $200 into a bank account. The bank gives her 3% simple interest each year on the amount she has in the bank account. I don't know if you know this, but if you keep your money in an interest-bearing account, the bank gives you money just for keeping your money in there, okay? So they give you a percent of how much you put in. So the more you put in, the more they give you, right? Because it's a percent or part of what you've got in there is what they give you. This bank gives you 3%, okay? Every year, they give you 3% on the amount that's in the bank. So she puts 200 in there. So they're going to give her 2%. I mean, they're going to give her 3% of $200 every year. They're just going to put it in her account. So what is her total balance after she keeps the $200 in the bank for 3 years? All right, this is simple interest. So we basically can figure out how much interest each year, then do that for 3 years, and then add it to the $200. So I'll show you what that looks like. So we've got the interest multiplied times the $200 or the deposit that she put in there is going to give you the interest per year, or interest rate, I should say. It's going to give you the interest for 1 year or per year, okay? So let's do that. So it's 3%, right? So if we write that as a decimal, it's 0.03. And the deposit was $200. So we're going to multiply the 0.03 times 200. And that's going to give us $6 for 1 year, or $6 per year, right? So if we have to do this for 3 years, we're going to take 3 years times $6 is $18 for 3 years. Okay. So if we take that $18 and add it to the original price, so we're going to go with the deposit plus the interest for 3 years, which is 200 plus 18, and that's going to give us $218. So the total amount after 3 years is $218. Okay, so that is how much money. If she just leaves that $200 in the bank, in 3 years she'll have $218 just for leaving it in there. So you can see the more money you leave in, if she put like $10,000 in the bank, 3% of 10,000 is going to be more than $6, right? So she will get even more. The more money you have sitting in there, the bigger the interest you're going to get in dollars. Okay. All right. So let's move on to a couple other examples. So One very popular example of using percents is when you go to a restaurant. Because when you go to a restaurant and you have a wait staff, people pay a tip in this country. Some countries, they don't pay tips. In Japan, they don't pay tips. But in the United States and a lot of European countries, you leave a tip, okay? And the tip is a percent of what the bill that you, so if the more money you spend, the bigger the tip is, right? So, but you also have to pay tax. So there's a couple different things that you have to calculate. So some situations require more than 1% to solve the problem. For example, when you eat at a restaurant, you pay tax on the food, and you also pay a tip to the wait staff. So the tip is also a percent of the price. Okay, so if the price of the meal isn't very big, the tip won't be very big. But if the price of the meal is really big, the tip will be really big. Okay, so let's do an example. Okay, the Maxwell family eats dinner at a restaurant, and the price of the meal is $60. The sales tax on the meal is 7%. They also leave a 15% tip. Now, sometimes people leave 20% tips. Some people leave 25% tips, very generous tip. So the percent that you decide is kind of up to you. Depends on if you're going to be a generous tipper. I usually tip 20%, but this problem says 15%, okay? So what is the total cost of the meal with the $60 plus the 7% tax plus the 15% tip? Okay, what's the total cost? So step number one, we're going to calculate the sales tax, okay? So we know sales tax is 7% of the price. So if we're going to do, so tax equals 7% of the price or the cost, right, of the meal. So we're going to take 0.07 times P, that's going to give us the tax. So if I do 0.07 times the price, we know the price was $60. If I do 60 here, I'm going to get $4.20 when I put that in the calculator. So right here, I'm going to write $4.20, okay? Now, the next step is to calculate the tip. Again, the tip is 15% of the price. Remember, the word of means multiply. So I'm going to take 15% as a decimal, multiply it times the price. So that's 0.15 times 60. And I'm going to get $9. Okay? So the tip is $9. The last step is to add the tax and the tip to the cost of the meal or the price of the meal. Okay? So we know that the price of the meal, we're going to go price of the meal or cost of meal plus the tax plus the tip is going to give us the total. So the price was $60. The tax was $4.20. The tip was $9. If we add all of that together, we get $73.20. So the Maxwell family, after tax and tip, paid $73.20 at the restaurant. All right. So that is a few examples of applying percent to real life situations. All of your learn and do is all kinds of different real life situations where they give you either the tax rate or they give you the new price, and you just have to solve for whatever is missing in the problem. Okay. And I'll definitely help you. So do all your learn and do. And that is the last lesson of Module 5. And when you finish the snapshot for Module 5 or 5.3, you'll be ready for Module 5 assessment.